This video, we're going to be tackling the binary tree level order traversal LeetCode question. And as usual, let's just go ahead and start off easy. Let's just talk about what exactly even is a tree. Many people might not even know what a tree is. And all a tree is a bunch of nodes, a bunch of pieces of data, a bunch of places in memory that are tied together via references. Now, if you don't know what references are, we'll talk about that more later, but just kind of hang on there. What exactly makes it so that you can chain all of these nodes together and they look like a tree? Like, you know about the node part and you can kind of see what's going on here, but what causes it to make it look like a tree? Well, you have a node and each parent can have two nodes under it, also called children. And that's pretty much what a tree is. But the bad thing, here's where things kind of get like, this is where LeetCode just takes a wrench and throws a huge wrench into everything. LeetCode is going to give you an array that is, and this array right here translates into this tree. So how does this array transfer over into this tree right here? Well, if you look, we've got 3, 9, 20. But what exactly are these nulls? These nulls are representative of the empty places underneath the 9 right here. Then we have 15 and 17. Now, it's not the way that I would do this, but that's the way that LeetCode does it. And the nodes or the array is actually transferred into nodes later on when you hit the submit button. So that's kind of the way, it's just the way LeetCode does things. I don't know, kind of strange, but it is what it is. So we need to create level order traversal. And level order traversal is easily explained if we just back up one place. In computer science, when we are working with trees, there is two ways that we can search or move throughout a tree. Traversal and search, they are technically two different things, but let's not get carried away. When we are traversing, when we are searching through a tree, we have two ways of doing so. We have breadth first search and we have depth first search. Depth first search is so easy, it's literally like 5 lines of code. But breadth first search is a little bit more complicated. We have to use a queue. Which one do you think we're using today? If you guess breadth first search or a derivative of breadth first search, you would be correct. And I say derivative of breadth first search because breadth first search is more made for trees. That's the difference between breadth first search and what we're about to do, level order traversal. But they are so similar, it's actually crazy. But let's talk about this difference, this breadth first search and this depth first search in a little bit more detail. If we're going to use depth first search, we're going to try to get to the bottom and find whatever we're looking for very quickly. We're just going to shoot towards the bottom as quickly as we can. And that's kind of the reason that they call it depth first search. But we want to use level order traversal, sometimes commonly referred to as breadth first search, but they are technically different. Make sure to know the difference. So breadth first search is going to go like this, and I have them individually numbered. We have 1, 2, 3, 4, 5, 6, 7. That is exactly how we're going to search. And if you notice it, we're going to go level by level. And that is the reason that they call it breadth first search versus depth first search. So let's go ahead and talk about how we're going to implement it. With breadth first search, we are going to implement it with a queue. We could use recursion, but it is a little bit more confusing. And all that's going to happen is, first things first, the way that we're going to actually traverse is we're going to start at number 1. We're going to go ahead and queue our first root node into the queue. Then this is where we start iterating. This is where we're going to start traversing through the tree. Next thing we're going to do is we're going to check to see if 2 is there. If there's a 2 node, we're going to go ahead, place it in the queue, and then we're also going to check 3 as well too. So we're going to go ahead, check 3. Once we get done with root number, the node number 1, we can go ahead, get it out of the queue, and we can move up our 2 and 3. And this process is going to repeat, and this is how we get breadth first search with a queue. So we're at 2 right here. Then we're going to go ahead and check if there's any nodes underneath it, and we're going to go ahead and enqueue them. And once we get done with them, the queue is going to act almost like a little piece of state. So we're done with 2. We can go ahead and we can move to 3, and we can go ahead, move up in our queue. And the same exact thing is going to happen, except we're just going to move this to the 3. And same exact process. We'll go 6, go ahead and put it in the queue. And 7, we'll go ahead, put it in the queue. And that is exactly how we're going to iterate through every single one of them. And as you can see, the queue just acts like a little piece of state that's going to remember where we are in the traversal. Let's go ahead, let's hop over into IntelliJ and let's code this thing up. So we are inside of IntelliJ, and the first thing that I'm going to do is create a brand new class. You could put this class anywhere that you want to, but I'm going to house it within the file where the folder where the main file is. And within this solution class, what I'm going to do is recreate the method that LeetCode wants us to write the algorithm in, and this is going to return a list of integers, just like that. And we'll call this level order, and go ahead, bring in the list, bring that down. So we need the tree node. LeetCode's going to give us the tree node, but one great thing about just going ahead and creating the tree node is that you learn a lot about how these tree nodes work in LeetCode. You may have wrote your own tree node, but sometimes it's good just to go through and see or recreate a LeetCode tree node just to kind of understand what's going on when you're actually creating all these algorithms, and it's kind of fun. So we'll go ahead here, and AI does everything for you. So we're going to create a second constructor, go down and assign these values within the constructor just like that, and we have created a tree node in just a couple, probably not even 30 seconds. So next thing that we're going to do is we need to go ahead and declare all our state. We're going to store everything, or we're going to restore what we need to return back in the form of an array list. I'm sure that you could do this with a array or any other data structure, but sometimes a list just works really great in scenarios just like this. And we're going to go ahead and import this. Also, we need to go into here and we need to put the actual what we plan to return within the generic brackets here. So first thing that I'm going to do is I'm going to go ahead and do a null check. You don't have to do this if you don't want to. If you don't care about the speed, it's not that big of a deal, but it really does increase the speed a lot if you do. Next thing is that we need to have a queue. If we're going to do breadth first traversal or level order traversal, whichever that you'd like to call it, you have to have a queue. In order to do that, we need to go ahead and initialize it. Also, we're going to add the root to our queue. And there's two reasons that we do this. We do this because number one, we're going to have to traverse the root in the beginning, so it doesn't make sense to do this before the iteration. And this also makes it so that we can add while loops as well too. So I'm going to go int level size. We're going to declare this as 0, and we're going to need to keep track of the level for the for loop. So we're going to have a while loop, and within this while loop, we're going to have a for loop. But before we actually make the for loop, we need to do a couple things. We need a list right here to keep track of every level. So here's how this is going to work. We are going to be required to return a list of list. And each time we iterate through this while loop, we're going to be at a different level. And once we get through all the levels, we're going to add them to the result. So the while loop is for every level, and the for loop is for each individual items for the level, if that makes sense. So we're going to go into here. We're going to say level.size. We're going to store the size of the queue. You could do it a different way. You could actually put this inside here, but all this data is going to be blown away here in a second. So we're going to have to keep track of the level size for each level that we go to. And we need that for the for loop. And then here is where we're going to actually remove the node off the queue. So whatever we added to the queue, we're going to actually remove it from the top here. So I'm going to say queue.poll, and you could call this poll, or you could call it remove. I'm a big fan of remove, but you could use poll. And here's where we're going to add the individual nodes. So we're going to add nodes so that we can add all the nodes to the level, and then we're going to add the level to the result. Hopefully that made sense. So we're going to say level nodes. If we called them, or we just called them level, I'm going to call them level nodes. I think that sounds a little bit more explicit. And we're going to go into here. We're going to say no, we're going to add each individual node. Then here's where we're going to add to the queue. You may have been wondering, well, when are we going to do this? This is where if we actually have children, this is when we're going to add them. This is when we're going to actually add them to the queue so that we can do the traversal later. Okay, that's looking good. After we get done with the if statement, we don't need to do anything else, but we do need to add all of the actual levels to the result so that we can finally return the nested array here. And then finally, after the while loop is when we're going to go ahead and return that result. So we're looking good here. Let's go ahead, toss this inside VS or LeetCode and see what we get. So let's go over into LeetCode. I'm going to go ahead, toss that in there, move this a little bit back. Let's go ahead, run it, see what our tests are accepted. Thank you, God. Let's go ahead, submit, see what our runtime is. So our time complexity N, our memory is N. We are good to go. We have passed the interview. Anyways, hope that you guys enjoyed this. If you did, smash that like button, smash that subscribe button. As always, thank you for watching.